guessing the first step is to take the y equals 2x plus 7 and plug it in at
Correct.
the y,
That's the
right?
substitution. What I wanted to show you is that every time we solve linear systems of linear equations in two variables in two equations, we can encounter one of the three possibilities. One solution, no solutions because the lines are parallel, or this is one line and this is the other. Yes, infinitely many solutions. So obviously the first situation and the third situation, systems are consistent. This system has no solutions is called inconsistent. Inconsistent system, consistent systems. Okay, so yes, in this particular example, one of the two equations is already solved for a variable. All we have to do now is replace the y in the first equation by 2x plus 7. And in this case, this little algebraic manipulation allows us to solve because we create an equation with only one variable. So this is 2x minus 3 in parentheses 2x plus 7 equals negative 13. This I know how to solve. Yes, perfect. So we have to distribute. So this is 2x minus 6x minus 21 equals negative 13. Combine like terms, yes. Negative 4x equals 8. So x equals negative 2. And remember we had y equals 2x plus 7. All I have to do now is replace x by negative 2. So 2 times negative 2 is negative 4. And negative 4 plus 7 is 3. So we claim that the solution is negative 2 comma 3. Am I certain? Oh no, I have no idea. Maybe. Exactly, awesome. So I have to go back with negative 2 and 3 and negative 2 and 3 and see if I get both equations to work. Negative 4 minus 9, negative 13, yes. Negative 4 plus 7, 3, yes. Only now I can say yes. I don't need anyone to tell me anything. I know for sure this is the solution and no one can find another. Any questions? Okay, this was substitution. But I would still like to look at 14. Same page. 2x plus 5y equals 1. And negative x plus 6y equals 8. If I want to use substitution on this problem, I have to make sure that I substitute or solve either equation for the variable that has a coefficient of 1 or negative 1. Will I solve the first equation for this? No. Will I solve the first equation for this? No. Will I solve the second equation for this? No. Because I'll have a fraction. And I don't want to deal with fractions. The only one that I consider substituting or solving for is negative x. So negative x equals negative 6y plus 8, and divide or multiply by negative 1, and I get this. This is what works. So I will go with this back to the first equation, replace x by 6y minus 8. So 2 parentheses 6y minus 8 plus 5y equals 1. So one more time, the system, in this system, neither equation was solved for a variable. We had to pick one. And we will always pick the variable that has 1 or negative 1 in front. What if I don't have that and I can simplify? Then I will not use substitution. I will use elimination. Okay? So let's distribute and find y. So 12y minus 16 plus 5y equals 1. 17y equals, look at that, 17. So then y equals 1. This is good, but it's not good enough. I have to determine x. So I go back here. So 6 times 1 minus 8 gives us x equals. Good, so the solution appears to be, I don't know for sure. Yeah, negative 2, 1. So I have to go back and plug it in. Negative 2, 1. Negative 2, 1. Negative 2, 1. Negative 4 plus 5 is 1, yes. Positive 2, positive 6, 8, yes. I don't need any help. I know this is the solution, and there is no other. Any questions on substitution? Piece of cake, you remember all this. Perfect.
Check, am I gonna get all the credit
You're going to get all the credit, yes.
if I don't check?
You will not get all the credit.
Don't check it, don't check it.
So please check. Please check.
There you go.
Let me say this. Is it part of the problem? No. It's not like taking squaring both sides. That is part of the problem, right? Is it part of the problem like in log equations? No. But it's so easy to go back and check and make sure you didn't make an error so you don't lose points. So I recommend it. It's very easy in these systems. It's a very good question, Taylor. It's very easy to make a mistake. A little sign messes up the whole thing. So in this case, I would say it's wise to check. It's not mandatory to check. Like in squaring both sides, remember the extraneous solutions. Or solving a log equation, if you don't stay domain, you have to go back and check one or the other. Okay, so moving on to elimination. Or we need another example with substitution. No, okay, awesome. Okay, so let's start with 24. Same page. 555. 2x minus 7y equals 2. 3x plus y equals negative 20. Yes, you could use substitution. Not for this x, not for this x, not for this y, but for this y. We don't want to do that. We want to use elimination this time, or the so-called adding method. Do we understand what the adding method is based on? No. Okay, so here it is. I'll point out how it works in a second. So I see here negative 7 and positive 1. I see here 2 and positive 3. This is a little bit more difficult to eliminate x, but it's much easier to eliminate y by simply multiplying the second equation, both sides, by 7. So now 2x minus 7 equals 2. And 21x plus 7y equals negative 140. Agreed so far? Yes? Is that clear? Yes, yes, of course. Okay, don't disregard the second equation for a moment. Now, when I say to you 2x minus 7y equals 2, I'm giving you a balance, right? The left-hand side is 2x minus 7y, but the same thing with 2. And the left-hand side is 2. So they are the same. If I choose to add 5 to both sides of an equation, will I change the solution? No. But this time I choose to add 2 to both sides of this equation. This is 2 that I add here, and this is 2 that I add here. I add the same quantity to both sides. They are the same. They look differently, but they are equal. So I will add this piece to this side, and I will add this piece to this side, because they are the same. Are they the same? Yes, that's what it says. 2x minus 7y equals 2. So this one is needed here, and this one is needed here, because they are the same. And that's how I get rid of y. So I add to both sides of the second equation 2. On one side, it looks like 2x minus 7y, and on the other side, it looks like 2. But they are the same. Because I'm allowed to add 2 to both sides in any form. Adding 2 to both sides of an equation will not change anything. But on this side, I don't want to write 2. I want to write 2x minus 7y, which is 2. But it's 2x minus 7y, that's what I need to eliminate the y. 23,
22,
x equals negative 138. So therefore, x equals negative 6.
I don't know how you do that. You like know the answer? My question, do you know that answer? Like, you're like, it's like, I'm like,
She's not half asleep.
No. Here's why. It's a very good question.
it's like, dude,
I
it's like,
asked myself, first of all, what do I multiply 3 by that ends in 8?
oh.
So what do I multiply 3 by that ends in 8? And that's the only answer. And then I said, okay, but is 6 times 2 12 plus 1? Yes, it is.
What the world? Yo, okay.
But that's the that's how you start. That's how you start. You ask, okay, 3 times what will be 8 at the end? And that's the answer. The only answer is 6.
You know, I wish my math teacher taught me how to cheat. Oh my goodness. Oh, you're
That's a
needing a
practice
calculator and you're
before
doing
you
it like
class.
with mental math, like, oh, peasant, you need a calculator. I know you're not saying that, but that's what I hear in my
Let
head.
me give you the answer.
Okay.
You started using this calculator probably when you were 5.
That graphic.
Yeah,
No,
7,
I used to when I was
Oh,
14.
9,
Actually, I didn't even use it when I
No.
was 14.
14.
I went through high
Yeah.
school without a graphic calculator.
Okay. Well, I started using it 20 years ago. I had no idea what this does
I didn't use it till high school.
because I didn't have something like this. I had no idea. I couldn't.
Ah, so it's a damn.
Privilege has made its jump.
There you go. There's the answer.
I had no idea when I started teaching. This is really interesting. When I started teaching here and I saw this, I said, "Oh my God, what do I do with this?" So I looked at it and said, "Would I be able ever to explain this to other people?"
You just did everything by hand.
I was like, it's impressive. Like, you know, if I see that now, I see now how you do the adaptation to your environment.
And for you, I will have to tell you a little story.
Ooh,
Yes.
You can learn. There's a lot of tricks that if you find the right person / tutor, there's a lot of tricks that you can learn
Right. Right.
to do that factoring.
So then, yes, negative 7y equals 14. So then y equals negative 2. So we expect the solution to be, we're not certain, because I could have made tons of errors on the way, negative 6, comma, negative 2. Is it true? I have no clue. I go back, negative 6, negative 2, negative 6, negative 2. So let's see, negative 12 plus 14. Yes, that's true. Negative 18 minus 2, yes, that's true. Therefore, this is yes. So let's go back and analyze this problem one more time. We realized that 2 and 3 were more difficult to eliminate. I did not want to eliminate x. I preferred to eliminate y because I only needed to multiply the second equation by one number, which is 7. Yes, please.
Can you multiply by a real number? Is it like
Yes.
if it was negative 7?
Yes, because negative 7 minus 7 is not 0.
Not in this specific equation, like say. the
Yes.
signs was-
Yes. So for example, if you want to eliminate x, you will multiply the top by, let's say, 3 and the bottom by negative 2. Or vice versa, by negative 3 and positive 2. Yes, of course. You can multiply by positive numbers, by negative numbers, not by 0. Not by 0, ever. Or divide by 0. So in this case, one more time, we chose to eliminate y because we only multiplied one equation by 7. In the next example, we will not have that choice. Okay.
You would just find which set would be easier due to the common factor.
Yes, the answer is I need to determine the smallest number that is divisible by 2 and 3.
Yeah.
The smallest number that is divisible by 2 and 3 is 6. Could I use 12? Yes, but that's not the smallest. Will you get the answer? Yes, the same answer, but it's not the smallest. Okay, ready? 26. Well, actually, 28, sorry. So 2x plus 3y equals negative 16, and 5x minus 10y equals 30. I didn't. It's good.
2x and 5x will be easier.
So if you want 2 and 5, then you will have to multiply one of the two equations by a negative number. But if you choose y, you will not have to multiply by a negative number. Will I be afraid to multiply by a negative number? No. Doesn't make any difference. However, what if I mess up a sign, which I can do very easily? So I'd rather avoid to multiply both sides by a negative number, but it's not a problem, really. So again, I would prefer eliminating y. Obviously, in this situation, we have to multiply both equations by something. If you multiply the top by 10, then you have to multiply the denominator by 3. So then 20x plus 30y equals negative 160. Please be very careful when you multiply. You have to multiply each and every term. Do not pick and choose, because then you're changing the problem. So then the second one is 15x minus 30y equals 90. And remember what happens here. I am adding this quantity that is equal to this quantity, right? I'm adding this one here and this one here. I am allowed to, because I'm adding the same quantity to both sides. So we met our target. We eliminated y. And then we have 35x equals negative 70. Therefore, x must equal negative 2. So this is good, but it's not good enough. I have to go back. It doesn't matter which equation you go back to. Negative 10 minus 10y equals 30, or negative 10y equals 40, and y equals negative 4. We claim, who knows if it's true? We don't know. So easy to make an error. We claim negative 2, negative 4. So I go back with negative 2, negative 4. I ran out of all my colors. I need new markers. So negative 4, say it again. Yeah, negative 4 minus 12, indeed, correct. Do I sound like that? Do you hear? Do you hear?
That's an exciting
hear?
class.
You know, I kind of feel like this is like yin and yang right now. Like that's what's happening. Almost literally, actually. Oh my goodness! Holy cow! This is that science. Is, oh my goodness!
That's what it is, a science class.
If that was art, like that would be like.
Negative 10 plus 40 equals 30, so I'll say yes. Any questions here?
Okay.
Any questions? Yes,
Can we do 18?
of course. Our next step is 18.
Wait, you've been doing this packet the whole time?
No.
Oh, 18 from the packet? Yes. No. I thought it was 18 from the book. I was looking at the book.
Someone using that.
Oh no, the NAP is not the solution. The solution is does anyone know what book? I don't have ID stuff. Never mind. I didn't bring that.
8x minus 4y equals 24. 4x plus 7y equals negative 6. I rigorously count my put numbers on my pages. One time I dropped them, and I had about 20, so I had to put them in a correct order. So I would never skip it. No. Okay. So I'm looking at this problem, and this is what I would do first. Obviously, I will divide both sides, the first one by 4. Because I can. And this is 2x minus y equals 6. 4x plus 7y equals negative 6. Do you have to do that? Not really. I mean, we can simply
Oh, so it's an
multiply the
extra step.
second one by negative 2 and eliminate x. It doesn't matter, really. I just wanted to simplify the top, and then I multiply by 7. It doesn't matter. You have so many different ways. So 14x minus 7y equals 42, and 4x plus 7y equals negative 6.
Makes the numbers a little easier.
Yes, yes, yeah, but if you multiply this one by negative 2, it still is going to be the same thing.
Yeah.
So then 18x equals 36. So then x equals 2. Of course, this is good, but it's not good enough. I have to go back with x equals 2. So I have 4 minus y equals 6, or negative y equals 2, or y equals negative 2. I have no clue whether this works or not. Especially on a test situation, I may make tons of errors. Who knows? So I go back and check 2, negative 2. 2, negative 2, 2, negative 2. 16 plus 8, yes. 8 minus 14, yes. So I will say definitely yes. And no one can find another. I want to look at one with fractions. Ready? What about 40? Do not ever, please, never ever be afraid of fractions. Please, they're so easy to eliminate. So 40. X over 6 minus y over 2 equals 1/3. And x plus 2y equals negative 3. Of course, I don't like having fractions in an equation, but it will only take a blink to get rid of them.
Do you think on the test we'll have a better chance of seeing a fraction problem? Will it be just more of a regular?
Well, this is just one extra step. You will multiply both sides of the first equation by, that's it. And what do you get? X minus, very good, equals, done.
I'm not scared anymore.
Good. Good. Please don't.
Do you think sex just
It's not a big deal, right?
Yes.
So obviously we will decide to eliminate x, because if you want to eliminate y, you have to multiply both equations by something to get the 6y and the negative 6y. So it doesn't matter which one. Let's say we multiply the first one both sides by negative 1, negative x plus 3y equals negative 2, and x plus 2y equals negative 3. Now, something I didn't say, but I'm sure you realize that terms with x have to be below terms with x. Terms with y have to be below terms with y. The equal symbol, because if you have this reversed, like if you have 2y plus x, you have to rearrange it to put them one before x below x and y below y, and the equal symbol below the equal symbol in the free terms, right? So please keep that in mind. So obviously we have here 5y, and we have negative 5, so y equals negative 1. And yes, we go back, and we have x minus 2 equals negative 3, which makes x equals negative 1. And look at that. Negative 1, negative 1. Does this work? I don't know. Have no clue. I'm not just saying it. I honestly don't know. I have to go back and check. So negative 1, negative 1, negative 1, negative 1. So the second equation is definitely a yes. I don't know if the first one is. So negative 1/6, but plus 1/2. Does this equal 1/3? Well, the least common denominator is 6. This one needs a 3. and negative 1 plus 3 will be 2 over 6, which is indeed 1 over 3. And I will say, yes,